Greetings. My name is John Gabriel. Welcome to my new calculus channel. In this part of what your ignorant teachers could not tell you, I'm going to be discussing some information about zero. So let's begin. Now, in past videos, we've talked a lot about zero, and one of the questions that always comes up is this one here. Is zero actually necessary in mathematics? Well, the brief answer is no, it's not necessary, because zero is not a number in a true sense. In fact, it's not a number in any sense, and it's used as a placeholder. In many ways, it's used as a placeholder in communicating number. For example, if we had to represent 302, so we have units, tens, and hundreds, and if we just wrote down 3 and 2, it could mean many things, right? It could mean 32, it could mean 3,200, etc. So that's why we use zero. So one of the purposes of the zero is to communicate the idea of which rational number we're talking about, the actual rational number we're talking about. So because we don't carry a template around like this, either in base 10 or any other base, we use zero pretty effectively in communicating which rational number we are referring to. Now, some might say that effectively what's happening here is that we're adding all these infinitely many zeros. No. In fact, all these here are blanks, and they're left as blanks when we decide to represent our numbers. So essentially, to represent 302 in our template, all we need are the digits 3 and 2. And so this is how we use zero effectively to communicate the idea of rational number, but it's not really necessary. Now, is zero actually a number? Well, let's see. First of all, if we have any particular equation, let's say x is equal to x. If we add zero to both sides, what has happened? Nothing, right? Nothing. So essentially, the addition of zero is a non-operation, okay? Nothing's happened. If we subtract zero, what's happened? Again, nothing, okay? So we know easily that the operations of plus and minus have zero effect where zero itself is concerned, okay? So now, some might say, well, it's in very highfalutin language that it's not defined or closed under division or multiplication, etc. But now let's take a look at, for example, division. Now we know that you cannot have zero as a denominator as part of any number, right? Let's say there's a digit or a number up here. You cannot have zero at the bottom because this denominator must signify how many equal parts of 1, always, okay? So this denominator always denotes how many equal parts of 1. Equal parts of 1. So if we, for example, had 3/4, it means we're looking at a unit that has been divided into 4 equal parts. Okay, and you may say, well, what about something like this, 8.23 over 9.45? Well, you can always reduce this into a rational number with an integer on the top and the bottom, and then conclude that this here is the number of equal parts of a unit, right? Okay, so we won't worry about that, but we'll still stay focused on this. So always this denominator tells us how many equal parts of 1 that we're dealing with, and 3 enumerates how many parts of those to give us the number. So the problem with having zero in here is that you would need to basically have a number k, right? Such that 1 divided by 0 is equal to k. And obviously this is impossible, right? So because 0 is not a number. So we know very clearly that 0 is not a number and cannot be manipulated with division, right? Now, multiplication came after division. So if you look at the previous videos, you'll see that if you have p divided by q like that, what this means is p divided by 1 divided by 1 divided by q, or it means q divided by 1 divided by 1 divided by p. Okay, that's what it means. Now, if p in this case is 0, then this here passes, okay? But if q is 0, it wouldn't work, would it? So if we have p times q, it means both of these must be true. Now, if p and q are any numbers, real numbers, both of these are true. But if either p and q are 0, then one of these is going to be false, right? So multiplication really isn't a valid process. So if we said x times 0 is equal to x times 0, that's just nonsense anyway, because multiplying any equation by 0 simply destroys all information about that equation. And it's invalid because if we have 0 times x, what it means is this. It means that this following operation must be possible. And what operation is that? It's this one here. It's this operation. 1 divided by 1 divided by 0, right? I'm sorry, that's multiplication. So it means that this here must be true, right? But it's not, because this here is garbage. Does that make sense? Okay, so I'm sorry, this is p multiplied by q, which means it's either one of these. So p divided by 1 over q is the same as p times q, and q divided by 1 over 1 divided by p is the same as p times q, right? So now we've seen that 0 is not a number in terms of any of the arithmetic operations, and none of them are valid where 0 is concerned. It's kind of strange, though, isn't it, that academics turn a blind eye and accept half of the multiplication as valid and the other half they just ignore, right? That's really funny. So, well, not really funny, it's actually pathetic, but they're stupid and they've never understood what it means to be a number, and they've never understood any of the operations. So what I wanted to show you in this video is that, well, 0 is not really necessary, but it's extremely useful. So we don't really want to get rid of 0 because it has many other purposes. For example, in an equation, if we had to, say, want to find the roots of that particular equation, then the equation actually has 0 value at these points, right? And so let's say if we had an equation f of x and we wanted to find the roots, we could write f of x equals to, and just leave this blank here. But the blanks are actually essentially the same as zeros, right? Because if it's equal to 0, it means it doesn't have any value that we could put into our template, right? So these are all blanks, and we could have left it blank or just signify that it's equal to 0. In other words, some value in here can make f of x equal to 0 at these points. And that's why we often talk about finding the zeros of an equation or finding the roots or zeros, right? So in the next video, I'll probably talk a little bit more about how we got algebra and what are equations and where we got them from. But all I wanted to do in this particular video was cover these 3 essential facts. So 0 is not a true number, it's just a placeholder, okay? It's a placeholder, and it's very useful in communicating the idea of rational number, because there are no real numbers, as we've seen in previous videos. Well, I hope you've enjoyed this little presentation. And also, I hope that you will subscribe to my channel and click like so that many more people can learn these interesting facts about mathematics and learn the well-formed mathematics, not the rubbish that you've been accustomed to in your school or university. So that will be all for this video. My name is John Gabriel. This is the New Calculus channel. Until next time, goodbye.